Hey there, welcome to my channel. In this video series, we are starting with the new series on maths for machine learning, where we will be learning about linear algebra and all sort of a thing. So, before getting started with linear algebra, I thought let me just bring out uh, how, how this from where this algebra word is derived from. So there was a mathematician, a Persian mathematician called Muhammad bin al Kharizmi, and he has written a book, the compendious book on calculus by completion and balancing. So basically, he wrote a book which is Kitab al-Jabr wa al-Muqabala. So basically, this mathematical term algebra is derived from algebra. So that's how we that's algebra came into existence, where he has it's one of the two operation which is used to solve a quadratic equation. That's on the algebra. So we have taken algebra from this. With that, I think let's get started on today's topic, which is gonna be algebra. Okay, so uh, if we have a missing value problem, let's say, so if I say something like this, and I ask you to tell me what is this possible value going to be. So as we are already used to these terms, addition, and it's a very elementary thing. So within a second, I can tell is this is uh, what this is what is the missing value. Okay, so instead, if I replace this square bracket with a term called x plus 2 and then solve it for x, we'll discuss that what is that solve for x means. So basically, this is where we can get what is that missing value, right? So basically, this is algebra. So with this, what we can tell algebra is basically arithmetic that includes non-numerical entities. So what we have a non-numerical entity here is this x. So like x is a non-numeric entity. So sometimes this is also called as variable. Okay, this is also called a variable. So let's see one example. Um, let's say I have a linear expression which is like this. Now, to solve for x, basically what we do, we try to balance them and take things from here to there. So obviously the sign changes, positive become negative and negative become positive. And the other way to look at it, let's say I want to isolate x. So what I'll do, I'll just subtract n from both the side first, and then after subtracting 10 from the both the side, But we'll end up with uh, 4x equal to 40. Then I'll divide by 4 on both the side, and what I'll get, x equals to 10. What does mean this mean? So this means that x must be equal to 10, because so x must be equal to 10. Why? Because if I put x as 10, so if I put here as 10, right? So we can say left, this is the left hand side, this is the right hand side. So this is left hand side, which is, so if I solve for this, right, I'll get 50 equal to 50, the balancing. That is why, that's what we determined. Okay, so that's about the algebra part. What is algebra? Now, if we know what is algebra, then also important for us to know what algebra is not. So let me consider one equation like 4x squared plus 2 equal to 12. Now this is not algebra because of this exponential term. Okay? Exponential term, right? So this basically is an exponential, and this is basically an exponential term. So if you have any exponential term, basically not a algebra. And to give you another example, the root of y plus uh, let's say 11 equal to 2. This is also not algebra, because this we can also yes y raised to power 1 by 2. So this is also not algebra. Okay. So solving for unknowns is within the system of equation, something we are going to see now. For that, so let's consider an example. Okay. So we have in a bank, have one bank, is a bank, and we have one robber. So this is your robber. The robber has a car which has a speed of 150 kilometer per hour, and have there is a robber. Obviously, there will be a police. Police. Police also has a car, and the speed of the car, this is 180 per hour. Now, and this robber goes to bank and do a, what it does, a bank robbery. Does a bank robbery, and police is updated about the robbery. It took around 5 minutes. Basically, the robber, after the bank robbery, the robber started running away and he has a 5 minute head start. He has a 5 minute of head start to the police. Now, with this scenario, now we know that there is a bank robber. He did a robbery. He has a 5 minute head start. Police also has a car. Robber also has a car, and their speeds are like ours is for is 150 kilometers, and this is 180 kilometers. We have to answer two questions here. So the first question is, the question one will be, how long does take the police to catch the robber? Question one. And let's say we have a question two. What distance will they have traveled at that? So, before moving on and solving these questions, I want to, for simplicity, let's ignore all the acceleration, traffic, and any other constraint which we think. We just assume that the moment that the bank robbery is done, the robber starts running at a constant speed in a straight road. Yes, we want to understand how to solve this. So, if you want to try, you can pause this video, and otherwise, we are going to know that is solution to solve this particular problem. Okay. So now this problem can be approached into ways where we'll solve the system equation algebraically. So let's look into that. Okay. So now one thing we know that let's say d be the distance and t will be the time. Distance is in kilometers, time in minutes. We'll see. Since we are considering time in minute, and also we know that the car speed was 50 kilometer per hour, and if I convert into minutes, it will be 2.5 kilometer per minute. Similarly, for police was 180 kilometer per hour, that will make it 3 kilometer per minute. Now, with respect to the public statement, so we know that t will be equal to 2.5 t. So this is the distance traveled by robot. So this is distance for robber. Okay. So let's say this is equation one. And similarly, distance for police car will be t minus 5 because the robber had a head start of 5 minutes. Now we know we have two equations. By comparing these two equations, we can actually get the answer for solve for the t. Let's say 2.5 t equals to 3 t minus 5, which is nothing but 2.5 t equal to t minus 15. Right? And again, taking this side, so we know that 2.5t minus t equals to minus 15, and minus 0 0.5t equal to minus 15, t equal to 15 divided by minus 2.5, which will nothing but this 30 is the time. So time is in minutes, so this is 30. That is the time it will take for to intercept the dropper. Now finding the distance is very easy. What we just need to do, we just need to take this value and plug into any of these values. So if I take this t and plug in into any of these two, right? So we'll get the value. So let's take this for calculate. So the t will be 2.5 into 30, and the distance will be 75. Now the distance is in kilometers. So this is gonna be 75 kilometers. So basically, this is the solution of this particular problem. Okay. Okay, perfect. So this is one way to look into this. We are going to discuss in another way. So this is an alternate way. The option two, we will be doing with the graphs. Now, before moving to that, so I want to tell you that this is if this is a line, so change in x y, and in y by change in x. So this is slope of equation, and the steepness and all will tell us the uh, slope of the line, right? So we'll be using, so here since we have minutes and kilometers, so we'll use our per minute distance traveled as a plot that, and we'll plot two lines, and then we'll see how this will help us to determine it. Let's say I I have this and this. So this is my this is the distance in kilometers, and this is my time, basically in minutes. Okay, this is the time in minutes. So now this is 0 0. So now for Robert, he's starting at the 0 region, and say we plot a line with a slope of 2.5. Now slope here is 0.5 because these are minutes, right? So every minute, how much distance it is traveling? So this is 2.5. And also, since this is 5, because police has head start, or the robber has a head start of 5 minutes, so police will start from this point. And let's say this goes like this. So this slope is equal to, so now wherever this point meets, this line meets, basically is the solution. So this is the solution. So what I mean with that, so we plot this, right? I'll show you in some time. Plot this. Basically, this t time is going to be. We are going to plot this and see this d, right? It's gonna be 75. So graphically also, can solve for this particular problem. This is an alternative approach which you can take to solve for x. This there are other two scenarios I think we should discuss before we conclude this. Uh, but prior to that, let me just show you how here. So this same problem I have uh, created it, and what we did is we created a time variable. Then we created equation for distance for the robber and distance for police, and then once we plotted these equations, we exactly found that at t equal to 30 minutes and distance at equal to 75, this point, these lines actually meet each other, and hence you know that this is the solution for the problem. Right now, this is having a this is a scenario when we say we have a this scenario when we have a one solution. So there are two other possibilities which might happen, which we should discuss. Uh, for example, let's say if we have the scenario something like what this scenario means. This scenario, what we are telling that this scenario, speed of our car equals to speed of police car. Okay? Police car. So basically, this particular type of problem we call it no solution. Is no solution. This this line will never meet. We can't find any solution for that. And similarly, the other case would be uh, the other case would be like this. If other possibility would be if the speed speed of the cars, so if speed of cars is same, plus they start at same point, start at same time, start at same time. So this is this particular problem. We call it infinite solution. Infinite solution. So these are the only three options in a linear algebra. It can be either one of them. Right? So when I say this, it can be either one solution, can be no solution, or it can be infinite many solution. Right. So this is somewhat the introduction about the linear algebra. The next video will start learning about factors, matrices, and other stuff. So stay tuned. See you in the next video.